destroying a boat to build a boat. I just cut off the head of the steering pedestal that was already done. I mean, sometimes you gotta do what you gotta do, and in order to make an omelette, you need to break the eggs. This is gonna be a great omelette. It's time. This week I'm gonna open a box that's been sitting on the entry of the workshop for the, I don't know, last 3 months probably. And it's a really important box, but I didn't want to open before it was time to shoot this video. There is something that we need to modify on the boat in order for this to work. So it's important for me to open and to understand the system so we can plan the modification on the boat. A few months ago we decided to simplify the boat. We are going to go fully diesel, not electric, not hybrid. We're going to simplify the electrical system. We're going to simplify a lot of things. Simplify don't necessarily mean buying the cheapest solution. It means buy simple and reliable solutions. This one is probably the most expensive one we could go for the steering system of the boat, but steering there is no compromise. We wanted the best steering, and that's the one we always wanted to have, because on our old boat Odd we had a lot of trouble with the steering. We broke the quadrant of the boat twice. This time that's not gonna happen. So this is our steering system. So we have a problem that the boatyard that designed our boat didn't design enough space for the system on the boat, even though they knew from day one that I wanted the system, and now it doesn't fit. So we need to fix something on the steering pedestal, and in order to do that I need to understand the system. So this is a gearbox. Each one of our rudders is going to have a gearbox to control the rudder, and the reason for that is because we are not going to use a cable system like usually you use on a sailboat this size. We're going to use a torque tube system. Inside this black box there's a lot of gears, and that means the force you apply to one of these shafts, it multiplies by 7 when it gets to here. For example, right now we have a really long shaft here and it turns. Here it's much easier because I apply a lot less force and multiplies by 7 the force that I apply here. That's just awesome. So that's the gearbox for the second steering wheel, exactly the same gearbox as the last one. By the way, this system is made by Jaffa in Denmark. So now that I have most of the components open, let me try to put them together on the floor on the right order so you understand how the system is gonna work. So awesome. Just to see the steering for the first time, the steering wheel, that's really special actually. I wish Roberta and Ollie they were here, but Ollie is taking a nap right now. Just to have the feeling of the steering, it feels like we're gonna have a boat. That's real, that's pretty cool. So the idea with the system is to have a system that can fail and it still work. So we have redundancy. The idea is that we have two completely independent steering systems that if something goes wrong with one of them, you still have the other one working fine. And the way we're gonna do that is by literally building up from scratch each one individually and then just connect them together in the end. So we have 2 steering wheels. So every time you rotate the steering wheel, it will rotate this shaft, and when you rotate this shaft, the gear inside this bevel box will transfer the rotation to this other shaft in the other direction, and this shaft is going to be connected to this torque tube by this crossing. So this cross is basically for alignment, because using this cross means you can have a certain angle. You don't need to be straight from the bevel box to the torque tube, and to a limit of course, and this cross connected to this little adapter connects to the torque tube, and then from the torque tube it connects to another cross and to the shaft of the gearbox. When you spin this shaft, it will basically spin the tiller arm, and this tiller arm is going to be connected to the rudder via a link, and here is the tiller arm of the rudder itself. So here is the rudder. The rudder has 2 tiller arms, one for the system, and this one is going to be connected to the second rudder via this link bar. So that means when you have both rudders connected together with the tie bar, they work as one system. But if you have any trouble in one of the rudders, you can just disconnect the tie bar and the second rudder is going to work by itself perfectly with no problem at all. You're just going to have less rudder area, but you're going to have a rudder, and that's really, really good. And the last component that I didn't show you is the autopilot. So this autopilot is going to be connected directly to the gearbox. That means every time it spins this shaft, it's going to also turn the tiller arm, that's going to turn the tiller arm, and that's going to turn the rudder. And that also means that the autopilot's gonna work a lot less, because on this end of the gearbox, it's 7/1. So every time it applies a certain force here, it transfers 7 times more force to the tiller arm. That's awesome, because you save a lot of electricity, a lot of power. This is a really oversized autopilot for our boat. That's the 24 volts version. We wanted a system that is just bulletproof and that's really strong for any condition. Both gearboxes are going to have their own autopilot, and that means we need to have an electrical system that cannot override each other. You can only turn one autopilot on at a time, of course, but if something happens to this autopilot, you just flip a switch and you transfer to the other autopilot, and then you have an autopilot working, and that's redundancy. That you can, at any point, you can just switch autopilot. The idea is to have 2 CPUs of autopilot and 2 actual autopilots. This system is just really, really awesome. Simple, and it works. It's just really strong, and I don't believe there's any part that can break. Like when you have like a quadrant with a cable, it's simple and it works. People have been using for years and years and years, but every now and then you break a cable, or every now and then there is like a slack cable, and this system is just a gearbox. And you say, oh, but that's a black box that you don't know what's happening inside. If you open this box, it's just a bunch of gears that anywhere that they have a machine shop, you can fix any part. It's just mechanical. There's nothing electronic. It's just a bunch of little parts that you can just open and replace one if you need. I doubt we will need to replace. So basically we are overpowered, and it's good to have spare rudder. I rather have spare rudder than have not enough rudder when I need, and that's safety. For me, a sailboat is all about rudder and mast. The rest you can play around, but mast and rudder, there's no playing around. You cannot save on that. I think it's important to have a really strong system, and that's bulletproof. Something really cool is that this tiller arm was custom made for us. I don't know if you see, but there is an angle, and this angle matches perfectly the angle of our rudder, because our rudder is not straight down. We have 2 rudders and they have an angle to the side, and that means when we put an angle on the shaft, this part is horizontal, precisely made for our boat. That's pretty cool. This other one has no angle because the gearbox also has an angle, so we just build the support for the gearbox on the right angle, and it's fine. I cannot wait to see this in place. Now I need to get the steering pedestal so I can start thinking about the modification. This bevel box is the support for the steering wheel on the steering pedestal, and this should be fully inside the steering pedestal, and as you can tell, this is deeper than this. I'm gonna think about a solution and I'll let you know next. Now I think it's going to be much easier to understand the problem. Under there is a lot more narrow, and here is a lot more wide. And that's the problem of that pedestal. It's pretty narrow. The bottom part is almost the thickness of that one. Of course, it's not exactly the thickness because I'm using 20 millimeters plywood. So of course I lose some space, but it's not even close to have space for this one. So now that I have the wide part on the top, I can easily fit this system inside here. I think I found a solution. You might be wondering, so where is this huge part? Yes, one more time we're gonna probably change everything. You see this line? The reason why I drew that line is because I'm considering cutting this pedestal here and just scrapping the top and just start with the bottom and build something like this. And there's a huge reason for that. It's gonna be a game changer for when you are at the steering and sitting. To be honest, I prefer that one much better. And I think that takes a lot less the view of who is sitting on the seat behind the steering wheel. Imagine that a lot of times you're gonna just sit here behind the wheel and want to see forward. I can see everything forward right now. There is no panel in front of me. The steering wheel, of course, is gonna be in front, but the steering wheel won't take the visibility much. When I'm standing up, it's flat. I can put things on the top. I can put my cell phone. I can have even controllers, the basic ones that I want. And in this one, it even feels too big. And whenever I sit here, what do I see? A beautiful panel. That's all I can see if I sit here, is just the panel. So that means it takes all the visibility. Even though it's beautiful, the panel, I don't want to keep staring at the panel. It doesn't make sense to me. So I think this one has to go. Of course, when you do a mock-up, you find problems on your solution, and that's why you do a mock-up. I just found out that if I want to open this hatch, it opens until it doesn't anymore. That means this doesn't work. I really like the shape. Also, when you're sitting here, it's less of a thing on you. That one, if I sit next to it, depends on who you are, your head can hit here. It's just, I don't know, it feels like you're too claustrophobic. It's just too much around. I think that one much better. How do you install a throttle here? This was meant for an electronic throttle. If you use an engine that is electronic throttle, there is no problem. It's just a cable that's you can turn the cable around. Our engine won't have electronic throttle. It's going to be a mechanical one. And a mechanical one, if you have ever installed a mechanical throttle, you will know that this doesn't work. The cable cannot travel from here to here. Or you need to install under here. That for me is just annoying because it's in the center of the steering wheel and then it's too low. You need to maneuver like going down. In this one you can install here because the cable can go down. It's easy to install here, it's no problem at all. But now let's get to work. I need to modify this one to see if I can come up with a solution that the door actually opens, and once we have that, that's the one we're gonna build. So here we have a first sample with the steering system in place. For sure a size that works. I don't know if you understand what I did, but I expand the box to the bottom because the system goes lower and we need this box lower. And the back now it's straight, there is nothing on the back, and in this way now the hatch of the lazarette can open. Yeah, we need to put this in place again and check in place to see what it looks like in place. Maybe that's the position, I think. I think I have the idea that is something in between the mock-up that I did and the original steering pedestal. And I think it's gonna work and it's gonna look good and it's gonna be easy and cheap to make. But there is one challenge on that. I want to finish this project using only scrap pieces of aluminum that we already have from the old design of the keel and the rudder, and I don't want to buy any extra material for that. Challenge accepted. So now that all the parts are cut to the right dimension, it's time for the trickiest part of this entire project. Not tricky because it's hard to do it, but tricky because after that there is no way back. And that's a big commitment because it's gonna literally change the look of the boat so much. But I do think it's for the best. And that is, I'm gonna cut the head of the steering pedestal off. And I'm gonna build something much lighter and better for the boat we want. But in order to do that, we need to risk. It's gonna look better, I hope. Let's do it. Destroying a boat to build a boat. So much better. Now that I already broke the eggs, it's time to make an omelette. Check out who came to visit. So what do you think? Is my project going well?
Yeah, I think it's much better without the head.
Feels much lighter.
Yeah, because one thing is to have a big head to have a lot of electronics on the top of it, but we are not planning on having it.
Yeah, the thing is, the truth is that a lot of times we use the iPhone or the iPad with the avionics, and a big screen right on the helm getting rain and salt water all the time is just not going to last for a long time. So we rather have a good chart plotter on the nav station that we can flip and see from the window of the cockpit than having one on the steering. And also because most of the time we're not behind the steering, we are sitting on the seat of the cockpit, and that means we won't be able to see the chart plotter with the pedestal as it was. Now, if we put it somewhere else, either on the table or on the bulkhead, we can see from everywhere, and that makes more sense.
And also we are having two pedestals, so we would need to have either two equipments.
Aluminum.
He's saying aluminum.
So we would need to choose one and have just one chart plotter and one pedestal, or we would need to have two.
And if we have just one, the other one would be just like a big head with nothing.
Yeah.
That doesn't make any sense.
Roberta.
Say my name.
By the way, the reason why I cut more than just this part is because, I don't know if you can see, but this part of the bevel box is outside of this plate. Yeah, so the carbon shaft is not gonna go parallel to the steering pedestal. It's gonna leave the back part where the steering is, and it's gonna have an angle towards the front part. So that means with this cut, I'm hoping that it can get to the angle before hitting here. So that's what I need to test now. If it hits, I need to cut a little bit more. If it doesn't, we're good to go, and then we just need to create the box around that. So now be honest with me, do you prefer this or you prefer this? But first, visibility test. If I sit behind here, as you know already, that's my view. By the way, that window is gonna open, and with this angle, you're barely gonna see anything. Now, with this one, do you see any difference? And I mean, we can have everything we need on this one. So I'm thinking about bow thruster controller, compass, windlass controller, throttle, autopilot controller, and extension for the VHF radio here. And then, if we need, because we might do that, we might create an extra start and stop button and a RPM meter for the engine, and we can put that here. Start, stop, RPM read meter, and then the controller, as I said before, is gonna be here. So autopilot is just like odd. You're sitting here and you want to change the course. You just reach and you can just control the autopilot. On both sides we have the same thing. And then the idea is that we can have a screen, if we want, there for instruments. So we put one big, I don't know, 7 inches or maybe even a 9 inches there and one there. So that means when you're in the helm, you can easily see the wind position and everything on that screen. And if we really, really want a chart plotter, the nav station is actually gonna be right here. So here we're gonna have a seat for the nav station, and the window that opens is right next to it. So we can easily create an arm that just flips the screen, and you can see the screen from here on the cockpit, and you can see from when you're sitting and when you're on the helm everything else, because if we get like a 12-inch screen, you can see from here, and that means the chart plotter is always safe inside without rain, without salt, humidity and everything. And that also means that when you're sitting on the cockpit, you can easily see and touch the screen right there. And most of the time you're sitting on the cockpit, you're not on the helm, you're on the cockpit. And when you're maneuvering, you can be here and you can easily put your phone on the top of the helm and just see the avionics on the phone, or you can just look at the chart plotter right there. And for me, that's more than enough, and that's the idea. Now you can vote. I'm not only talking about how it looks, I'm talking about how it looks, how it feels to use, how much space it takes, how useful it is, how practical it is, everything together. And I can see that's a huge discussion, because there's no right and there is no wrong. For a lot of people, that's the perfect solution, for sure, because you have everything at your hands. You can have a chart plotter, we can have all sorts of panels, but that's not us. For a lot of people, this is also the best solution, because it's a lot more simple, it clears a lot the visibility, it feels lighter, it's just, I don't know, I'm biased, I prefer that much better. But let me know, what do you think? I was gonna tack weld in place at least that one today, but I think it's not a smart thing to do that, because I need to know 100% what instruments I'm gonna have there, otherwise I'm gonna make a mistake. This is on hold now until the equipments are here, and then next week I'm gonna work on a project that I've been waiting for a long time to get this done, and that's really exciting. I see you in the next one.